In this video, I will be talking about a very important concept in math. We will learn how to find general term or nth term of a sequence. This one method will be very useful for all sequences. Those are described by polynomials. For example, polynomial of second order or polynomial of third order. Alright, so let's first start with a linear sequence or a sequence which is given by a linear equation. So let's take an example. The term of the polynomial of the sequence are 11, 19, 27, 35 and so on. Though to find the nth term of a linear sequence, multiple methods are there, but I am focusing on one single method which is called the difference method. So what we will do, we'll find the difference of two successive terms like that. So this difference is 8. Again, we can see here the difference is 8, and here also the difference is 8. Now, this difference is called first difference. And the rule is, if the first difference is same, then this sequence must be given by a linear polynomial. This is the rule. If the first difference is same, then the nth term will be given by a linear polynomial. So let's see that linear polynomial. It's suppose I'm writing that linear polynomial. It's suppose an plus b. Since it has to be a linear one, so I'm just taking it as an plus b. Now let's say this is the first term of that linear polynomial, that's the second term, that's the third term, and suppose this is the fourth term. So since this is going to be my general term, so I'm substituting the value of n as 1, 2, 3, 4. If I take n as 1, my term would be a plus b. If I take n as 2, my term would be 2a plus b. If n is 3, of course it is 3a plus b, and if n is 4, it should be 4a plus b. So again here let's find the difference. This difference is a, here also the difference is a, and here also the difference is a. So as per the rule of the difference method, if the first difference is same, then it is definitely a linear polynomial. So we have checked it here also, that since the first difference is same, so it must be given by a linear polynomial. You can in fact do it in the exam also. You take the sequence, find the difference. If the first difference is same, it will be linear polynomial. If the second difference will be same, it will be given by a polynomial of second order, which means a quadratic polynomial. And if the third difference will be same, definitely the sequence is described by a polynomial of third order or a cubic polynomial. So that's the method. Now at this stage, we will now compare the terms. So you can see in this general expression, this is a at the bottom, and in the comparison that we draw here for the difference, this is 8. So we can compare both these two. So a is equal to 8. Now let's go for the second value. In this one, the second one is a plus b, and this sequence thing, the first one is 11. So if I note this equation also, so it is a plus b is equal to 11. Now I have in a way these two linear equations, and I'm supposed to solve equation 1 and 2 to find out the values of a and b, and then we can substitute them back in the general term. So by substituting the value of a as 8 over here, we are getting b is equal to 3. So with both these values, if I go back to my general expression, which is Tn is equal to an plus b, my a is 8, so it is 8n plus 3. So that's the polynomial, the general term polynomial, which can describe this equation. Let's check it out, this sequence rather. Let's check it out. If I say n as 1 t1, it is 8 into 1 plus 3, which is 11, and this is exactly the first term of my sequence. Let's say t2, so n is 2, so it is 8 into 2 plus 3, which is going to be 19, and this is exactly the second term of my sequence. Let's take one more example. When n is 3, it should be 8 into 3 plus 3, so it is 27, and we can see that this is the third term of the given sequence. So this means this particular expression, this particular nth term is clearly defining, describing my given sequence. Now for the second example, let's take a sequence which is given as 3, 9, 17 and 27. So we will follow up the same method. We'll find out the difference first. We have no idea whether it will be a linear or a quadratic one. So just find out the difference, and we can see in the first case difference is 6. In the second case the difference is 8. While 27 minus 17 the difference is 10. So one thing is very clear, that this first difference is not same. Since this first difference is not same, so it is not going to be a linear sequence. So what we will do, let's find out the second difference. 8 minus 6 is definitely 2 and 10 minus 8 is definitely 2. So we can notice that here the second difference is coming out equal. So as per the rule, since the second difference is equal, this sequence is definitely given by a polynomial of second order or a quadratic polynomial. So it is given by a quadratic polynomial. Alright, so since it is a quadratic polynomial, so let's describe it as Tn is equal to an square plus bn plus c. Definitely this is the general term of any quadratic expression. Now let's build our terms. This is T1, this is T2, this is T3 and this will be T4. So T1 means in the Tn expression I am going to put n as 1. So this is definitely a plus b plus c. My T2 would be 4a plus 2b plus c. T3 would be 9a plus 3b plus c, and T4 would be 16a plus 4b plus c. Now if we find the difference of the terms here, so 4a minus a, it must be 3a plus b. In this case, if we find the difference, it should be 5a plus b. And in the last case, if we find the difference, it should be 7a plus b. Now clearly first difference is not equal. This is our first difference and it is not equal. So it is not going to be a linear one. Actually we are looking for the expression for a quadratic one. So we'll have to find the second difference. This is 2a, and here also we notice that the difference is 2a. Now since the second difference is equal, so it can be exactly compared with the above expression of the numbers. Now let's start comparing. This is the bottom number which is 2a here, and here is the bottom number which is 2. So this means the first equation that I am getting is 2a is equal to 2, hence my a is going to be 1. Similarly, let's compare this middle number which is 3a plus b, and in this case the middle number is 6. So if we compare, 3a plus b is going to be 6, since we already know the value of a is 1. So from here b will be 6 minus 3, hence 3. And now this is the last term from this one and this is the last term from this one. So we can compare these two also. So this is a plus b plus c is going to be 3. A is 1, b is 3. So we can find the value of c. So from here c is coming out as minus 1. So if we go back with all these values to the expression, the Tn now would be a, which is 1, so it is just n square, plus bn, b is 3, so it is just 3n, and c is minus 1, so it is minus 1. Now let's find out whether this answer is correct or not. So for that, let's try to find out T1 first. So if I find T1, which means my n would be 1 in this case, so it is 1 plus 3 minus 1. It is giving me 3 as the first term, and if you check in the sequence also, 3 is your first term. Let's find out T2. This means n is 2 now, so it should be 4 plus 6 minus 1, so it should give you 9, and you see the second term of the sequence is also 9. Similarly, if I do it for T3, it should be 9 plus 9 minus 1. So 18 minus 1 is definitely giving you 17, and 17 is your third term of the sequence as well. So we can see that this difference method is very helpful in finding the nth term or the general term of a sequence. The only thing is you have to look for the difference. If the first difference is equal, your sequence nth term is going to be a linear one. If the second difference is equal, the nth term will be given by a quadratic expression or a polynomial of second degree. Alright, now let's continue the method to find out about another polynomial sequence which is given as 5. The first term is 5, the second term is 33, then we have 109, and we have 257, and of course we have 501. So with all these numbers, if we find the difference, first difference, this is going to be 28. This difference 109 minus 33 should be 76. 259 minus 109 should be 148, and 501 minus 257 should be 244. So one thing is clear, this is the first difference and the first difference is not equal. So we should go for the second difference now. 76 minus 28 should be 48. 148 minus 76 should be 72, and 244 minus 148 must be 96. So we can see the second difference we have calculated, and the second difference is also not coming out equal. So let's go for the third difference now. 72 minus 48 should give you 24, and 96 minus 72 should also give you 24. So we can see now the third difference we are talking about, and third difference is definitely equal. So since the third difference is equal, this sequence must be given by a polynomial of degree 3. So a polynomial of degree 3 must be a cubic polynomial. It must be a cubic polynomial. So I write my expression, general expression for the cubic polynomial here as an cube plus bn square plus cn plus d, because this is a general expression for any cubic polynomial. Now let's find out the terms, different terms. So let's say this is my t1, I will write my t2 over here, this should be my t3, somewhere here t4, and somewhere here my t5. So if I write all the values with n is 1, t1 means n is 1, so I'm getting it is as a plus b plus c plus d. With n as 2, it must be 8a plus 4b plus 2c plus d. With n as 3, it must be 27a plus 9b plus 3c plus d. With n as 4, it must be 64a plus 16b plus 4c plus d. And of course with t5, it should be 125a plus 25b plus 5c, and of course plus d over here. Now let's find the difference between this 8a minus a. So this is going to be 7a plus 3b plus c. And if I find the difference over here, this should be 19a plus 5b plus c. The difference between these two should be 37a plus 7b plus c, and the difference between the last two must be 61a plus 9b plus c. Now if I find the difference between these two, this must be now 12a plus 2b. The difference between these two must be 18a plus 2b, and the difference between these two is 24a plus 2b. So we can see this was the first difference which is not equal, this is the second difference which is not equal, and now we are finding the third difference. Let's see if it is equal or not. So the difference between these two is 6a only, while the difference between these two is also 6a only. So we can see that now the third difference is equal, so it is definitely given by a polynomial of cubic order. So obviously this has to be, because we are comparing it with a cubic polynomial only. Let's compare the terms. The number at the bottom is 6a and the number over here is 24. So if I write them together, 6a is 24 gives me a as 4. This case 12a plus 2b, 12a plus 2b, 12a plus 2b can be compared with 48 from here. So it is 48 from here. Now since a is 4, so it has to be 48 plus 2b is equal to 48. So this gives you b is equal to 0. Again, for the next comparison, we have 7a plus 3b plus c. 7a plus 3b plus c, and which is equal to the next number, which is 28 from here, let's put the values now. Since a is 4, so 7 into 4 has to be 28, plus 3 into b is 0, this value is 0, plus c is equal to 28. Overall, if we solve it, c is also going to be 0. And let's compare the last term, which is a plus b plus c plus d from here and just 5 from here. If we compare these two as well, a plus b plus c plus d is equal to 5. Let's put the values. A is 4, b is 0, c is 0. So only d is left, which is going to be 1. So now if we create that expression over here, let's write it over here. So my Tn is now an cube. A is 4, so it is 4n cube plus bn square. B is 0, so that value is 0. C is 0, so this value is 0. And d is the last one, which is 1. So I'm writing plus 1. So this means the nth term of the sequence is 4n cube plus 1. Now the only thing is left, we need to check whether we are correct or not. So let's put T1, n is 1, so it is 4 into 1 plus 1 is 5, and yes, the first term of my sequence is also 5. Let's say T2, now n is 2, so it is 4 into 8 plus 1, it must be 33, and we can see yes, the second term is 33. If I take the third term also T3, it is 4 into 3 cube, which is 27 plus 1. This number must be equal to 27 into 4, which is 108 plus 1. So this is 109. So we can see definitely the third term is also same, which is 109. So this is a very versatile method. It can give you the all the sequences which are described by different polynomials. It may be a linear, or it may be a quadratic polynomial, or it may be a cubic polynomial. All can be solved like this using the difference method. Find out in the exam also, take the question, find the difference, and depending on you are getting the first difference, second difference, or third difference equal, you can decide whether you should start with a linear polynomial or a quadratic polynomial or a cubic polynomial. So this is the method. Understand it clearly, and it will be very helpful in the exam. Thank you. Well, if you could understand what I was trying to explain, please like and subscribe to my channel. And if you want to be notified for my next video, please press the bell icon also. Thank you.